In Lesson 9, we'll be reviewing points, lines, rays, line segments, angles, and perimeter. Now, Part A is on points, lines, rays, and line segments, and the reason we talk about all these together is because they all have some things in common. Now look at that white circle that I've drawn there. Think about that as a point, like a period on a piece of paper, like in a newspaper. You were reading along and there's a period at the end of the sentence. Now if you magnified that period or that point, it would look a whole lot bigger. But just think about within that point or period, you could draw a bunch of other points inside of there. Those could also be magnified and you could draw more points inside of those. So in terms of mathematics, a point, it really has no size at all, but we put a dot to identify that point or location. A point, it identifies an exact location in space. Mathematically speaking, we can't really show the location of a point. It's just such a small thing. We represent the location of a point with our pen or pencil by just drawing a dot. Now if we connected a bunch of points together, that would be called a curve. And a line, that's basically a straight curve that does not have ends. And it goes on forever and ever. That's why we put arrows on the end of them to represent a line going on forever and ever. Mathematically, since a point, when we think of it mathematically, it doesn't have any size, a line has no width either. We represent its location with our pen or pencil by drawing a line pattern. Now to identify the location of a line, all we need are 2 points. We'll just call these A and B. And we could write that, we could say that is line AB. And we can say AB with an arrow, or with a line symbol over the top of it, or we could write that BA as well. Doesn't matter. We could put another point on there as well. All we need to identify that line are 2 of those 3 points. So AC, that's also representing that particular line. CB would work as well, BC. We just need 2 points and only 2 points to represent the location of a line. Think about it over here to the left. If we just had 1 point, we can draw an infinite number of lines through that 1 point. If we have 2 points though, there's only 1 line that can go through those 2 points. That's why when we define the location of a line, we need at least 2 points. Now a line segment, that's just basically part of a line. So we could take from A to B, keep the dots, and put a segment in between A and B. And so that's what that is. It has ends. A line segment has ends. And we can write that AB with a bar over it, no arrows on the ends because it's a segment. It has ends on it. BA also works, segment BA. So line segments, those have ends. And then lastly, a ray, that's basically half of a line. It has a dot at one end like a segment does, and it just goes on forever in one direction, and only one direction, not both directions. And it, like a line or a line segment, needs at least 2 points to represent it. And so here we could write that as A, B with an arrow over the top. Now we would not write that BA with an arrow over the top. The arrow needs to point in the same direction as the order of the letters. A is at the end, so that's the side that we put the endpoint side for our symbol that goes above AB. And then the B is closer to the arrow side of it, and that's why we wrote it like that. We wouldn't write it like this. You can't do that. So mathematically, a point that has no size to it at all, it represents an exact location. We use a pencil or a pen point mark to identify its location. Lines, those are a series of connected points, and They're a curve basically that's straight. They go on forever in both directions. We need at least 2 points to identify the location of a line. We need at least 2 points to identify the location of a line segment as well. Those are like a line except they don't have ends, or they do have ends. And then half a line, a ray, that's what that is. It has one end and then the other end goes on forever. Let's go ahead and do some practice problems. Look at practice problem A. What I want you to do is name a line, 2 rays, and a line segment from that figure that I have there. So one line that you could say is line XY. You could also say line YX, but let's just go ahead and say line XY and just put an XY with a line over the top of it. And then 2 rays that you could draw from this are ray XY and then also ray YX. And notice the arrow on that ray YX, it's over the X, so basically I'm going from the Y to the X. If you're going in that direction, then the arrow goes that way. So ray YX, I could have drawn it like this, or let me just show you something else just so you can understand. I could have drawn it like that as well. And a line segment that I could do could just be XY. I could also do YX, but you don't put the arrows on the ends when you do the segment. Let's do another problem. In this one I've given you some dimensions. From A to B, or segment AB, is 8.2 inches. From A to C, or segment AC, that's 19.5 inches. I want you to tell me what segment BC, what that length is. And so you can see there you've got a total length from A to C. You could subtract out 8.2 inches. And so just do a subtraction problem. 19.5 minus 8.2, and you'll have a 3 there, 1 here, 1 here, 11.3. So that's what BC would equal, is 11.3, and then inches for the units. Don't forget to put your units on problems like that. If they give you units, make sure and write down some units. A lot of times you'll see problems like this in the book, and they'll give you the values or the dimensions in numbers on the paper. They won't identify the dimensions in red like I've done. So what you want to do is go ahead and identify those dimensions like I've done in red, and that helps you think about how to set the problem up. And are you doing an addition problem, or are you doing a subtraction problem, to find that missing line segment that they asked you to find. Part B is on angles. In Part A we covered points, lines, line segments, and rays. Angles are basically 2 rays that have a common endpoint. So one type of angle that's important to know about is a right angle, and the way we do that is draw one ray perpendicular to the other ray. One straight up and down, the other one is left and right basically, or horizontal, the other one's vertical. We put that little box in the corner to represent that it's a right angle. When you see that little box, that tells you it's a right angle. The measure of that angle from here to here, that's 90 degrees. So usually what we do is we think of all other kinds of angles relative to a right angle. For example, an acute angle, it's smaller than 90 degrees. And an obtuse angle, that's greater than 90 degrees. And then a straight angle is basically, it has a common endpoint here, one ray to the right, one to the left, and it's 90 plus another 90, it's 180 degrees. It's basically 2 right angles. Go back over to the right angle. If you had one right angle here and then you drew another one back to back, that would be 90 plus 90 is 180. So I've written the names of those angles, those types of angles, in red there, and those are important to remember. Right, acute, obtuse, straight angles. Now on acute and obtuse, those can be any measure of angle. An acute angle, that's just any angle that's less than 90. So that would mean like an 89 degree angle, an 84.5 degree angle. Just any angle less than 90 is called an acute angle. An angle greater than 90 is considered obtuse. Two 90 degree angles back to back, that's like a straight angle. 180 degrees is its measure. The measure of an angle is found using a protractor. And if you have a protractor, you know, like what you do with that is you set it up and you center it at the vertex, or where the two rays meet. Like look at the obtuse angle. The two rays meet right there. And so we would take this protractor, it kind of looks like a half a circle basically, and we would center it right at that point. The protractor has little marks on it and numerical values that represent the particular angle measure, and we just line it up and we figure out what that angle's measure is. So the angle measure is kind of like the gap in between the two rays. Make sure you know the difference between a right, acute, obtuse, and straight angles. Let's look at part C on perimeter. And perimeter, basically that means measure around an object. And what you're doing here is, like if you have a flat two-dimensional shape. For example, let's say you had a rectangular shaped yard and you were going to fence that yard. And rectangles, the opposite sides are the same lengths. Let's say this is 20 feet, and that little one tick mark, represents the word feet. And let's say this side was 60 feet. You wanted to know how much fence you needed to buy in order to fence your entire yard in. Well, what you would do is just measure the perimeter of your yard, and you just add up the different lengths of the sides. And so you just start with 20 plus 60 plus another 20 side and another 60 side. So you basically have two 20 sides and two 60 sides. You add all of this together. I'll add up in pairs here. 20 and 60 is 80. Plus another 20 and 60 is 80. That equals 160. So we need to write our units down as well. Feet. And I'll write the word out this time, or the abbreviation, FT for feet. And so when you do perimeter problems, all you're doing is you're measuring the lengths of all the sides together, and then you get a total length for all the sides combined. That's what perimeter is, the distance around an object. Now on this type of a problem, I think the units are just as important as the numerical answer. Like if you went to the store and you said, well, I need some fencing for my yard, and they said, well, what's the perimeter of your yard? And you say 160, and they give you 160 yards of fencing. They think you meant yards. You're going to pay a lot more. You're going to have all this extra fencing left over that you have to go back and return, and it's just a big pain. If you would have told them 160 feet is my perimeter and just said instead of just saying 160, then they would have known the units, the correct units, and they could sell you the appropriate amount of material. So on geometry problems like these, the units are just as important as the numerical part. And so that means if you get the numerical part wrong, but you get the units right, then you should still get half credit for your answer. If you get the numerical part right and the units wrong, again, half credit for the answer. Look at practice problem C. Let's find the perimeter of that object, and we'll assume that all of the sides, their units are in inches. And so first, let's just go ahead and make a mark, or make a path around this object. We know that perimeter means distance around the object. Let's start with this side of length 6, and I'll just go 6, 4, 9, 9, 2, and then we need this side, but we don't have a value for that length right there. So from here to here, we need to figure that out. And what we would do is we know this distance right here is 9 inches. And then we know this distance from here to here is 4 inches. Subtract those two from each other, and this missing distance would be 5. So that's a good idea to do what I did there at the beginning, is just take your pen or pencil and follow a path around the perimeter of that object and just add up and make sure that you know the length of all the different sides. If not, there will be enough information there to find the missing sides that you have. So now let's go ahead and add 6 plus 4 plus 9 plus another 9 plus 2 plus 5. And what I like to do when I'm adding a bunch of numbers like this is add them up in pairs. 6 plus 4 is 10, and then I write that addition result right underneath each pair. 9 plus 9 is 18. 2 and 5, that's 7. Now I can do 10 and 18, that's 28. Plus 7 is equal to 35. Now remember, that's half the answer. The other half is the units, and the units are inches. So the perimeter of that object is 35 inches. Let's do one more. Let's figure out the perimeter of this shape. So we'll just start and we'll make a path around it first and make sure we know the lengths of all of our sides. So we'll go up here and start down at the bottom left. Doesn't matter where you start really, but I'll start at the bottom left, go up 24, 36. Now I don't know that side. I'm going to have to figure out from here to here. That's 24. This is 16. I don't know that length right there, so I'll need to know from here to here. And I'm putting those tick marks on the ends there just to help me remember that I need to know that distance. I know that's 4 and that side is 36. So there are 2 lengths that I need to know here. On these problems, when you do them in the book, they'll tell you that all of the angles are right angles, and you can use that to help you figure out which sides are equal and things like that. So I know those top and bottom lengths are the same. They're both 36, and that inside one, since everything's at right angles, this must be 24 here as well. Now that top segment that I still have to figure out, I know what distance is from there to there. That's 24. And then I also know from here to here, that's 16 plus 4, right? So that would be 20. So this has to be 4 in there to get a total of 24. Now I can go ahead and add up, and I'll start with 24 plus 36 plus 4 plus 24 plus 16 plus 24 plus 4 plus 36. Our units are inches on this one as well. Now go back and add in pairs, and 24 and 36, that would be 60. Plus 4 and 24 would be 28. Plus 16 and 24, that would be 40. And then 4 and 36 would also be 40. So we can add in pairs again. 60 and 28 would be 88. 40 and 40 would be 80. That adds up to 168 inches. And so that's the perimeter, 168 inches. On these perimeter problems, one thing that people mess up on a lot is you forget to write down all of your numbers that you need to add together. That's why it's a good idea to first just make a path around the perimeter of that object, and that helps you remember what all your numbers are, and then you can count them up too, and you can see you have 1, 2, 3, 4, 5, 6, 7, 8 numbers that you should write down and add together. On a problem like this where you have lots of things to add together, you need to put in place some things to help you eliminate error or reduce your chances for error. So making a path around it to find your missing sides, adding up or counting all of the sides to see if you have the same amount of numbers in your addition, those things are important things to do to help you prevent mistakes. Don't forget your units too on perimeter problems. Okay, well that's all for lesson 9.